Hey guys, this is our last page of notes that is over MultiStep Equations. This one has the subtitle Variables on Both Sides. Today we're going to be looking at equations that have variables on each side of our equal sign, and our goal will be to move all of them to one side with all the constants on the opposite side, and then in the end to get our variable all by itself so we can solve for the value of the variable. So I'm going to start with the steps to solving. Throughout this process we've kind of built upon our steps, and these are kind of the same, except now the first step is going to be directed at doing something to each side. So step 1 is to simplify on both sides. I could say each side, but I'm going to say on both sides. And in order to simplify and go through that process, you will need to distribute and or combine terms. Then our second step that we're going to follow is to get all the variables on one side of our equation. So we're going to move all variables on one side and all constants on the other side. We'll do this by adding or subtracting them in order to move them. So get all variables on one side and all constants, that's just your regular numbers, on the other side. When doing this, you want to try to make everything as positive as possible, and instead of negative. I mean, if you're good with negatives, that's fine, but I always try to say, okay, which side would it be best to move these on so everything's looking positive and I'm not messing with my negatives. And again, you're going to do this by adding. I'll just say add or subtract. So that's the method you're going to use to do this. Then you have step 3. I'm going to slide that up a little bit. Step 3, you will divide to eliminate coefficients, or you'll multiply to eliminate denominators. So divide to eliminate coefficients. And that's the one we use most often. Or multiply to eliminate denominators. That was a long one. Alright, so now that we have our steps written down, we are ready to solve some of these. I will be using several colors today because we will have to combine some like terms, so keep that in mind. So let's work a few examples together. The first example we're going to look at, slide that up. Example number 1, I'm going to start it really slowly and gradually build upon with throwing in distributive property for you. We have 9m minus 28 is equal to 2m. Now, since you're used to it still, I am going to split the two sides of my equation because some of these are going to be kind of tough. So I see that I need all my variables on one side. Now I already have a variable over here. I have 2 m's over there, and there's not a constant over there with them. Now typically, like I said, I would prefer to keep things as positive as I could, but in this case it's going to be easier for me to move 9 m's over here with my 2 m's. So let's move 9 m's over to the right hand side by subtracting 9m from both sides. When I do that, the 9 is eliminated from the left-hand side, and now I'm left with negative 28 is equal to the difference of these two, which is negative 7m. So I didn't have to combine anything. I didn't even have to do step 1. I skipped 1, went straight to 2. Now I'm on step 3. I'm going to have to divide to eliminate my coefficient of negative 7. So we're going to divide both sides by negative 7. When we do, we find that the value of m is positive 4. And that's our answer. Number 2. Number 2, we're going to start with 5 minus 7n is equal to 11 minus n. So I added a little bit to this one. Going to start the same way. Let's split our two sides. Step 1 tells us to basically distribute or combine terms on both sides to simplify. I can't really do anything here. So now I need to look about moving all variables to one side and all constants to the other. Looking at this, I do have 7 n's over here and only 1 over here. So I think it's going to be easier just to move that 1 n over here with the 7. He is negative because he's being subtracted. So let's add this one little n to both sides. And we are just moving all of our n's to the left-hand side of our equation. So now on the left, we have 5 minus 6n, because I have to find the difference here, equals 11. Now this is just a standard two-step equation that you should be used to by now. We need to take our 5 from the left and move him over to the right-hand side with that 11. So we need to subtract him. He is positive, so we'll subtract him from both sides. When we do that on the left-hand side, we are left with negative 6n equals, the difference here is in fact 6. So now we're on step 3, and we do have a coefficient, so we need to divide both sides by negative 6. And we find that the value of n is in fact negative 1. And you can see that this second problem was just a little bit lengthier than the first one. So I kind of went a little bit more there and gave you something extra. So we're building these equations. Look at all my pens I'm holding in my hand. Alright, number 3. I'm going to kind of move it up here just so that I can place number 4 down here. So you lay yours out however works for you. Number 3, 7 times, so open parentheses, x plus 4, close parentheses, equals 82 minus 2x. Alright, so now I'm actually going to have to work with number 1. And number 1 does tell me to simplify, and I'm going to have to use the distributor property here. I'm going to have to take this factor of 7 and multiply him by every term inside parentheses to expand this. So now I have 7x plus 28 on the left-hand side equals 82 minus 2x. Now, if I had something to do on this side, I could have done them both at the same time and just brought it all down. But I didn't have anything to work with on the right-hand side that needed simplifying. Okay, now we need to start moving all variables to one side, all constants to the other. Hopefully you're noticing it's going to be easier to move this minus 2x to the left-hand side and the 28 to the right-hand side. Now, once you get good at this, you can do them both at the same time, but we're not going to do that today. Let's start with the 2x. Let's move him to the left-hand side by adding him to both sides. When we do that, on the left, we are left with 9x plus 28, and on the right, we're left with 82. Now, time to move all our constants to the right-hand side, so we need to subtract 28 from both sides. Look at the numbers, they're just reversed order. Just totally noticed that. Now, on the left, I'm left with 9x equals, the difference of these two numbers is 54. And now I'm on step 3, which tells me that I need to eliminate my coefficient, which is 9 in this case. So let's divide both sides by 9, and you should know what the quotient of 54 and 9 is in your head. It is 6. So x equals 6. Look how much longer this problem was compared to the first two. So they're getting longer. So they're going to continue to get longer as we keep working. Okay, now we have number 4. Number 4, I'm going to put two different things that we need to distribute. So we're going to start with -3, open parentheses, and I'm going to try to fit this. This space is small, and I'm going to try my best. 4x plus 3, close parentheses, plus 4, open parentheses, 6x plus 1, close parentheses, equals 43. I barely made it. Barely. Okay, let's go ahead and split our two sides. I'm going to come down a little bit further with my line this time. I've been running out. Alright, the first thing we need to do is start distributing. We're going to distribute the -3 to every term inside the first set of parentheses. Then, at the same time, on the same level, we're going to take the 4 and distribute it to every term inside the second set of parentheses. So when we do this, the product of -3 and 4x is -12x. The product of -3 and +3, watch how I write this, is -9. I just put -9. That's the same thing as plus -9. Now I'm going to bring down our plus sign. The product of 4 and 6x is 24x. The product of 4 and 1 is indeed 4. Equals 43. Okay, we are actually still on step 1. So we distributed, but now look what we got on the left-hand side. We need to combine some like terms. I have two different x's here. I've got -12 and +24. I need to combine these guys to do a little simplifying. So -12, +24, they make a +12x. And now they're not the only things over there I need to combine. I need to notice I have two constants that need to be combined. -9 and +4. When I combine those, I end up with -5, and I'm going to write it like I did that -9. So 12x minus 5 equals 43. We got to get ourselves in the mindset that -5 is the same as plus -5. Alright, now let's move our 5 to the right hand side with the 43. So we're going to add 5 to both sides. 5 is now gone on the left. I have 12x. And on the right hand side, I end up with 48. And this is going to work out nice and evenly to give me a wonderful whole number. So when I divide both sides by 12, I end up with a value of x is 4. And I barely had enough room to fit this problem. Can't believe I made that work, but I did. So, yay me! Now, you won't always get a whole number every single time. So don't be worried if you get a decimal or a fraction, a rational number. I mean, it happens. We're going to do one more problem, and then we're going to end there. So I'm going to have to turn my page here to fit number 5. And you can see through where I've written, but that's all right. So we're going to have to do one more, like I said. And this one is going to be the longest one so far. So no flipping out on me. Number 5. I am thankful to have this room. -12m plus 4m, so you should already be thinking, hey, I can put those together, minus 5 minus 9, you should be thinking I can put those together, equals 8m minus 13m plus 15 minus 8. Alright, hopefully you're not flipping out on me. So I took out all the distributing here. No distributing to be had. So I don't know why some of you are stressing right now. However, I do have several terms I need to combine. So on the left-hand side, our negative 12m's and our 4m's, they can go together. I'm going to go ahead and do the same thing on the right-hand side because I have 8m's and negative 13m that can also come together. So on the left, now I have negative 8m, and on the right, I have negative 5m. So just bear with me. I know we're working the left and right at the same time, but that's okay. That's okay. We can do that. We're talented. We got this. Then negative 5 and negative 9 can also go together. And on the right-hand side, positive 15 and negative 8 can go together as well. Negative 5 and negative 9 come together and make a negative 14. I'm going to put minus 14, not plus negative. Then on the right-hand side, 15 minus 8 is 7. It's just positive 7. So I'm going to put it plus 7. Now I need to do some shifting. I say let's move our m's to the left and our constants to the right because I would be adding this 14 and this guy's already positive. So let's go that route. So let's go ahead and move our negative 5m. So let's add him to both sides. My paper's like rolling on me here. And then what I do on the left hand side, I have negative 3m minus 14 equals 7. Now we need to take and do the same with our 14. Let's add him to both sides. I know that looks weird, but you guys should be able to figure out 7 plus 14, even though it does look weird. On the left, now I have negative 3m equals 21. And the last thing I need to do is divide both sides by my coefficient of negative 3. The value of m is negative 7. So I really hope that you guys have paused some of these and tried them on your own and gotten them right. The biggest thing to remember when working these is to show every single step. Don't skip them. And I know some of you guys are really having a hard time of just showing all those steps, but you've got to get that down, okay? So get these. These should be in your notebook. This is topic 66 in your notebook, so go ahead and record that, and then I will send out to you the practice that goes with it. Have a great day.